Alright, so just some basic definitions that you've probably heard in middle school, but translations, it moves every point of a figure in the same direction. So component form is also known as vector form. You might have seen this before, but it is where you see something like this with arrows like this, so like it'd be 5, -2. And it's following the XY format, so that would move the figure 5 units to the right. Because that's the +5 means 5 forward, and then 2 units down. So you'll see translations written in a variety of ways, but that's just one of them that's not as familiar to students usually. So if you see something that looks like that, that's what it means. Okay, image is what we call the new figure after we translate it. And it's just important to recognize that the new figures are already always marked with the same letter and then an apostrophe after it. So on your exit ticket today, like there'll be some figures and they just ask you what happened to the second one. Just know that the image, the new one, is the one with the apostrophe. And then pre-image is just the original figure. And so, for example, it would be just plain A. So you'd see A and then A with the apostrophe. Alright, so then when we translate it, we can do this 2 ways. We can either label these points and then just do the math, subtract 6, because it's saying to translate it x minus 6, y plus 8. And so we can do the math and just subtract 6 from every x value, add 8 to every y value. Or we can sit there and count it out and graph it and then plot it. How many of you think it'd be easier to label and add or subtract? How many of you think it'd be easier to graph it first and then label? Okay, so more people said label and add or subtract. We had a mixture. So we're going to, let's go ahead. These are for the new coordinates, so let's label on the graph. Can someone tell me what the coordinates of A would be?
2, 3.
2, -3. So 2 over, 3 down. Okay. And then how about B?
2, -8.
2, -8. How about C?
8, -8.
Do I want to know a shortcut? This graph, like you have to check, not every graph is this way, but this graph is 10 units each, so like I know that's 8, -8 real quickly because I just subtract the 2 from each. So, if that helps. If it confuses you, ignore it. How about D?
8, -3.
And E? 5, -5. Okay, so if I'm just doing the math and I take point A, which is 2, -3, what is my new x-coordinate going to be?
-4.
Yeah. Okay, so I'm getting like 1 or 2 people answering. So just if that didn't make sense to you, I'm just taking 2 minus 6, which gives me negative 4. And then I take my negative 3 plus 8. What's that give me? 5. So negative 3 plus 8. If you like to do it that way, that's a way to do it. Sorry, that's... Okay. If the other thing we can do is we can actually sit here and count. So negative 6 means I count backwards. 1, 2, 3, 4, 5, 6. And then up. 1, 2, 3, 4, 5, 6, 7, 8. And label my new A. Because a lot of times you're asked to graph it and label it. Or I can do the math and then plot the point. That's negative 4 and 5. Alright, so B. I think I should I use popsicle sticks? Make sure everyone's awake. Or should I call them people who look sleepy? Alright. Do you guys all know your desk numbers? Okay. So if I draw your stick, you've got to give me an answer. And I drew 3. We're no one's in 3. So how about desk 28? Alright. What would you say our new coordinates for B are? And have everyone try to do it on your paper while she finds the answer. So B would be negative 4. And then what was the second one? Negative 4 and 0, because we go over and up. Or we do that as a subtraction, minus 6. I'll say it again. Alright, desk 19. I think that's Miracle. Are you in 19? Or Elizabeth? Okay. Yeah, you're in 19. So, what do you think C is, Miracle?
Maybe 2.
Okay, 0, yes. Is it negative 2? Yeah. Positive 2. Because when we just go here, it hits right here. So C is positive 2 and 0. Alright, desk 9. Victor, what about D? 2 and 5. And desk 26. Oh, you guys change places. Jesse, what do you have for?
What room is this?
It's E204. So just like through that direction.
Okay.
So Jesse, what'd you say for E?
Negative 6.
So start with the positive 5.
Negative 1, negative 1.
Yeah, negative 1.
Negative 1. Negative 1 and plus 3.
Positive 3. And I forgot to plot the D. So D, E. And then when I connect the points, does it look like I did it correctly? Yeah, so when we translate, the figure is always going to look exactly the same. It's not flipped over like the reflections we did. It's just moved, and everything's moved like that. Okay, so in this one, we are describing it with a rule, which just means tell me how did it move. So if I move from A to B, how many units, first of all, am I going to A to B, am I going right or left?
Right.
I'm going right. How many units am I going right?
4. No, 5. 5.
So it's 5 if I count 1, 2, 3, 4, 5. But because I need this corner to line up with this corner, right? So I have to match point to point. So if I'm taking this corner right here, I have to match it up with this bottom corner of the B. So 5, how many is it to get all the way over here?
10.
10. Mm-hmm. So I could write it as x plus 10 because right means I'm going forward. And so that's plus. And then up or down?
Down.
And how many units down?
10. 5.
and then y minus 5. Because we just came down 1, 2, 3, 4, 5. And then if I did the vector notation, it would be written like this, just 10 comma negative 5. So do you guys see the difference between those parentheses? We have the x plus. If it's this notation, we just put it that way. You can do either, just know, like on test or quiz or homework assignments, you might see either. Oh, I forgot. There you go. All right, so I'm gonna actually no, just with your group, see if you can label the next two, okay, and then compare your answers to your group. And so then the vector notation would be the minus 12, comma minus 1. So when you have all that, flip over to the next page. Okay, so this is, if you do it correctly, you'll have a nice little drawing in the middle of this that will make sense. So what you're going to do is, my classes last year got really mixed up with this. Do you guys want to do this together, or you want to try it in your groups? You want to try it in your groups? Okay. So we're going to take like 3 or 4 minutes, see how much. So plot those points, and then move every single point to x plus 2, y plus 1. And then if you don't understand like the connecting the points part, we can do that as a class. And so it made a cube when we connected them all. Okay, our definition for rotations would be just turning a figure around a fixed point. Okay, so rotations, it just means we turn the figure around. This was the one when we did that project before Thanksgiving that was, I know, a little harder for people to see. Okay, so then this is your little cheat sheet for rotations, and it works really well for some people, and it really confuses other people. Okay?
What was the definition for
Center rotation is the fixed point.
No. The definition.
Okay, so and we're going to go through what this looks like, and y'all did it some before Thanksgiving, but if you want to come back here and say, okay, if we're moving a point from here, from this quadrant into this quadrant, it will rotate from AB, we'll switch place, it'll become negative B and A. So if I had like 1, 2, it would become negative 2, 1. Hey, Emily. If I rotate it 180 degrees, it's just going to change sign. So like if it goes from here to here, they just both become negative. If I start here to there, they both become positive. And then if I'm going all the way to here, they switch places, and then the A becomes negative. Okay, if that makes no sense to you, that's okay. It might make some more sense later, or if it doesn't make sense, you can just do what we're going to do next. But this is kind of like a cheat sheet, a summary of it, if that helps you. Okay, so on the next page, we can either rotate clockwise or counterclockwise. If you don't know what clockwise and counterclockwise are, I have a clock up on there, and you can look and see how it's going, or you can come back here. But clockwise just means we turn the paper this way. Counterclockwise means we follow the arrow, turn it this way. Okay, so it's determined by degrees. So 90 degrees, if I changed 90 degrees into a fraction, like turning my paper all the way around as a whole number, would that be like a quarter, a half, 3/4? What's 90 degrees going to be?
1/4.
Yeah, so it's just a quarter. So I just turn the paper sideways. How about 180? Half, yep. How about 270? 3/4. And 360? If I rotate something 360 degrees, is it changing at all? No. Alright, so down here, I'll just take volunteers for this. What changed to get A on its side like this? Was it?
Clockwise.
It was clockwise 90 degrees. If I was turning it counterclockwise instead, how many degrees would it be?
90. I mean, 480. I mean, 360.
270, right? It's not getting all the way back around, but I could turn it this way, then down, then back over. So it could be, or 270 counterclockwise. Are we being kind and respectful? Encouraging our friends? What's your question, Victor? P would be 90 counterclockwise, yep. Or how many if we did clockwise? To the 270 again. And anyone, how about the last one?
Me.
Alright, what'd you say?
Clockwise 270. I mean, 180.
180. And so here's the thing about 180. Does it matter if it's clockwise or counterclockwise? No, so 180 is one that it often won't even tell you which direction because it doesn't matter at all. You're just completely flipping it upside down. Yeah, you don't, I mean, sometimes they might tell you in the problem, but often it'll just say rotate 180 degrees. You can just put straight 180. Okay, so the way we did this when you did the project before Thanksgiving is we just had you turn the paper and label the points, right?
Yeah.
Is that what you guys did? And so to me, that's what makes the most sense. But before I do that, if I'm going, so that's asking me to go clockwise. So when I go 90 degrees, it'll come over into this section, right? And then 180 is going to go here, 270 will go there. And so the easiest thing to me is to take this picture and draw it 90 degrees, turn it 90 degrees here, and then I just label the points. I'm going to do it up here in this empty space. When I've turned it like this, what's my A? So it would be 2 and 4. What is B when I turned it this way? Who wants? 7, 7. And then C, 9. Yeah, 9 and 3. Okay, so when I rotate things 90 degrees, my new points will be these. And so then I just turn my paper back, and I plot those new points. I know I'm looking at them sideways, but I go 2, 4 is my new A. 7 and 7 is my new B. And then 9, 3 is my new C. Does that look, I'm sorry, you guys couldn't see that well. Does that look like I've taken it and just flipped it over, rotated it 90 degrees?
Yep.
Some yes, some no. And if it helps, I have this just to demonstrate. If you have like a see-through piece of paper, you can put on it, and like I can trace out my graph, trace out my original shape, which this is not something you're going to do because we're in high school, we're learning how to work it out without things, but this is just to show you. And I can check and just turn it. Yes, I did it correctly. It rotates perfectly on top of it. And then I can rotate it this way and see, okay, so when it comes down here, it's supposed to rotate like that. When it comes this way, it should rotate like that. The other way we could do it is, so here, if I labeled these points, so the original points was -4, 2, and this was -7, 7, and this was -3, and 9. And I could go back to the chart they gave us on the page before where it said, okay, if it's going from here to here, I reverse the order, and this is my positive quadrant, so everything becomes positive. So I just could take both of these, and this changes to our 2 and 4 that we found over here. Reverse the order, they're both positive. Reverse the order, they're both positive. Reverse order, they're both positive. It's just your preference. Is it easier to count it out, and regraph it? To me, that's just kind of the most simple. But if you want to memorize the patterns and do it that way, you can. Okay, so then if I do go to 180 degrees, I flip my paper all the way upside down, and then count out, and I'm just going to write it up here. And I'm doing ABC with 2 marks this time to show this the second rotation. So what was my A this time? And are either of those negative? For -2, right? And how about B? 7, -7. How about C? Okay, and so then I'm going to turn it back over. Did anyone notice, and I know we have them upside down, what changed between my numbers to go 180 degrees?
Yeah, they switched.
Did they switch places, or did they just change signs? Well, but from here it did. But from my original one, so like -4 and 2, became 4 and 2. So when we do 180 degrees from the original, all that changes is the symbol. When we do 90 degrees, they flip places and signs. All right, so go ahead and graph that on yours. So 4 and -2. And I'll put this back on and see. Yes, I did it correctly. Alright, can you do the last one on your own? So turn it 270 degrees clockwise. See if you can graph, like label the points and graph it out before I show you mine.